Hello, this is Miss Moore, and today during chemistry we're going to discuss the kinetic molecular theory. Today's essential question: how does the KMT or kinetic molecular theory describe the motion and behavior of a gas? The kinetic molecular theory. The kinetic molecular theory, or KMT for short, is the simplest model for the behavior of a gas. In this theory, a gas is modeled as a collection of particles, and the particles can be either atoms or molecules. So in this theory, a gas is modeled as a collection of particles in constant motion. Let's go over the basic postulates, or assumptions if you prefer, of the kinetic molecular theory. Okay, postulate or assumption 1. Gases are composed of tiny particles whose size is negligible, meaning just almost doesn't count, it's so small, compared to the distance between them. So, this means that the volume of the actual individual particles in the gas can be assumed to be negligible compared to the volume of the container. Okay, so basically, these particles are so tiny, and they're also very, very spread out. And the volume of one particular particle is almost nothing compared to how much space a whole gas takes up, because they're bouncing around, they're moving all over the place. Okay, so this means that the total volume of a gas, the total volume that a gas fills is almost all empty space. Hugely important there. There's lots of space between the particles, and so the volume that a gas takes up is mostly nothing, empty space. Because of this fact, gases are compressible. What does compressible mean? It means they can be squished into a smaller space. Because there's lots of space in between each particle, you can actually take them and squish them down smaller and smaller and smaller. The space, not the particles themselves. But the total volume of the gas can be squished into a smaller and smaller and smaller space. Okay, assumption or postulate 2. Gas particles move randomly. They're just bopping around. But they do move in straight lines in all directions and at various speeds. Okay, so they're just moving around. They don't curve and stuff like that. They just go into a straight line until they hit another gas particle or the side of the container, in which case they bounce back off and continue in a different direction in a straight line, and as you'll find in a minute, the same speed that they were at previously. Okay, and the forces of attraction or repulsion between two gas particles is negligible, meaning they're not really attracted to each other. They don't want to hook up, nor do they want to get away from each other. Okay, they're not repulsed by each other. They're basically don't care about each other, if you want to think of it that way. So the forces of attraction or repulsion between two gas particles is negligible, except when they collide. Not with, but when they collide. So think of each gas molecule as independent from all of the other gas molecules in a sample. They all behave independently. All right, basic assumption number 4. When gas particles collide, when they bang into each other, these collisions are what we call elastic. And this is really important because honestly, most collisions are not elastic. Most collisions you are familiar with are not elastic. So what does an elastic collision mean? Elastic collision means that there is no loss of kinetic energy after the collision. So when two gas molecules bang into each other or bang into the wall of their container, they bounce back off at a different direction, but with the same speed. Same speed. They don't lose any kinetic energy. And that is compared with an inelastic, So a gas molecule will move at the same speed before and after a collision with another gas molecule or the sides of a container, only the direction will change. Okay, so an inelastic collision, in case you didn't get that, inelastic collision is collisions you're probably more familiar with. So an inelastic collision, think about two cars. They're driving down the road in opposite directions and they smash into each other, okay? Head-on collision. What's going to happen? Close your eyes and visualize this. Likely, the cars will bounce back apart, right? But they won't bounce back apart at the same speed and just keep going, right? They will hit each other, bounce off each other a little bit, slow down, and eventually come to a stop. That kind of collision, those cars have lost kinetic energy. That is an inelastic collision. That's not true of gas particles. Gas particles, their collisions are elastic. They just bounce off each other and keep going on their merry way. All right, and now, ladies and gentlemen, the last assumption. The average kinetic energy of a gas particle is proportional to the Kelvin temperature. So all calculations involving gases should be carried out using the Kelvin scale. And believe it or not, that's it for today. Have a good one.